Okay, you guys, here's my first attempt at this recording with a slideshow. Let's hope it goes all right. Um, this is going to be just a couple slides on the electrical conduction system of the heart. I want you to get to know it kind of geographically because familiarity with it is going to help you to recognize what's going on an EKG tracing and then think back to what nodes and what bundles and what branches are then being stimulated to formulate that EKG tracing, all right? Um, so that electrical stimulus does control the mechanical pumping action. What happens electrically should be then corresponding with a mechanical action inside the heart. It doesn't always happen that way. You can have electrical activity without mechanical. In that instance, you probably have some kind of a sick um, muscular group, either from a heart attack or just a weakened heart in general, that electrical conduction then doesn't transmit through to the muscles to make them contract. But for this purpose, we're going to assume that everything is working as it should. So the components of this system are, the main components are the SA node. In between the SA node and the AV node, we're going to remember that we have internodal pathways. There are several different pathways. I just want you guys to know that there are those different pathways. I'm not expecting you to learn each one by name. Then we have the AV node, which then leads down to the bundle of His and the right and left bundle branches, and then that finally terminates in the Purkinje fibers. You have to think about this conduction system as very similar to your house wiring, where that wiring is going throughout that muscular system, the myocardium, etc., of the heart. And as that electrical wave travels through the heart, it essentially is stimulating the cardiac muscle to contract, and then that just forms a pumping action, whether it's the atrium or the ventricles. It's really that simple. And we can follow that electrical pathway on our EKG tracing and then determine if there is some kind of cardiac dysrhythmia, a rhythm that is not what it should be. We can figure out what is going on mechanically with the heart if that is corresponding to that bad rhythm. So that's why it's important to know these specific little parts here, okay? So let's go on to the next slide, which will then give us a good illustration of what's going on there. So this is your heart. Here we have our right atrium, right ventricle, left atrium, left ventricle, okay? Here's aorta coming out of there. We don't really have a whole lot of the other vessels on here because we don't really need them for this purpose here. So somewhere up in that ceiling of the right atrium is the SA node, the sinoatrial node. It is considered the master pacemaker of the heart. If everything is normal, it's going to beat on its merry way about 60 to 80 times a minute with its own inherent pacemaker rate. Now that rate is going to be flexible depending on the needs, the oxygen demand of the body, etc. Stimulation it gets from the sympathetic nervous system, stimulation it gets from the parasympathetic nervous system. Either one of those can speed up or slow down the heart respectively. But all things considered, if you're just chilling in a chair, this SA node is going to beat between 60 and 80 times a minute. So when that node fires off, it then carries the electrical impulse through those various internodal pathways. And again, I don't really need you to know the names of the different ones, but just know that those pathways then are going to continue through the atrium, both right and left, stimulating that muscle to contract, which then remember from the previous lecture on how the heart pumps, both of those atrium are going to pump simultaneously. Something else to note too that we'll get more into with EKGs, these internodal pathways are insulated as well to keep any electrical stimulation from going down and exciting the ventricles to contract prior to them being filled. And that's an important thing to remember as we get more into cardiology and EKGs and how the heart is pumping. So we'll touch more on that later on as well. Once that electrical stimulus has gotten through the atrium, they've contracted. It then gathers up at the AV node, this blue little nodule right there, where it is paused ever so briefly, about 20% of a second, a fifth of a second or so. And that pause in the electrical conduction is to allow the blood then to get contracted from the atrium and fill both ventricles simultaneously. Again, if that electrical impulse goes down too early, too prematurely, and excites those ventricles to contract before they've been fully filled, that's going to affect cardiac output and overall circulation in a negative way. So the way the heart is designed, we have that ever so brief pause at the AV node that allows both ventricles to be filled simultaneously. Once that pause occurs, the electrical conduction then goes down through the bundle of His. Once it passes through there, it starts stimulating the septum, the septal muscle walls to contract or to be excited. And then the right and the left bundle branches is where this is like a superhighway, super fast conduction happens here. So as those are being stimulated, then it's stimulating all those ventricular cells to contract, hopefully simultaneously. So we have a nice even contraction of both the left and the right ventricles simultaneously. The Purkinje fibers are just the very small fibers that go within the muscles to ensure that all those little cells are stimulated to contract simultaneously. All right. So as this is SA node, interventricular nodes, internodal pathways, AV node, brief pause, down the bundle of His, left and right bundle branches, and out to the Purkinje fibers. As all that's happening, then we can simultaneously figure out what's going on as a tracing, and that's described in our PQRST complex as they got named, which then is formed in a tracing on your EKG. So if we look at each little part here, and I'll try to get the corresponding color, as the SA node fires off, that's what formulates the P wave on our EKG tracing. So that's our P wave formulating right there in that color green. As it's going through the internodal pathways, we get that tracing continuing on here. And I'm just doing the different colors so you can kind of get an idea of where the electrical activity is at that particular time. Once those atrium have been stimulated or contracting, then remember we get that brief pause at the, I'm going to do it in this color so you can see it, at the AV junction, which is represented by that PR interval right there. And I'm not doing this drawing to scale, but I'm doing it just so you get an idea of what is going on. All right, so we have that brief pause there. Then the electrical conduction is kind of, let's see this color here, going through the bundle of His and then down through the left and right bundle branches. So just so you get that, you can't really see that color that well. It doesn't work. I'm just going to do that in the orange. And that is where we get our QRS tracing as the electrical activities going through the left and right bundle branches. We get that QRS complex. And again, not to scale, but because it's not ever that wide, that's what's going on there. That's what represents that. And then finally, we get a return, and I'll just go in black for that, a return of all those cardiac muscles kind of resetting themselves. And that's what happens when we see that T wave on there, okay? So that's our T wave. T wave right there. QRS complex is represented by that big fatty right in the middle. Oh, this is tough to draw, I'm sorry. That's it right there. Okay, and then the P wave is what is representing the atrial depolarization and then mechanical contraction right there. So all that put together, we have our P wave, QRS complex, and our T wave is what we're seeing on a normal EKG as this is happening in a normal fashion. So I could draw more lines, but it'll just probably mess this up. But essentially that's what's going on there. Internodal pathways are happening right around this timeline there. The QRS complex is what's going on there. And then the reset of the entire heart, or I'm sorry, the ventricles, is represented in the T wave. Somewhere in the QRS complex is the electrical reset of the atrium, but that's being overwhelmed by the large amount of electrical activity in the ventricles, so we don't really see that tracing on our QRS complex, all right? So there you have it. I do expect you, and you'll see that in one of the quizzes, to be able to recite the pathway and corresponding branches and nodes, etc., of the electrical conduction system of the heart. All right, that's it for now. Hope this isn't too bad. Thank you very much.